In this video, we're going to look at how we draw vector diagrams in momentum. So, the steps that we need to follow here. The first thing is to draw the vector for the initial momentum. Then we need to draw the vector for the change in momentum. And then lastly, we must draw the vector for the final momentum. The vector for the final momentum must start from the tail of the initial momentum to the head of the change in momentum. Now, how we approach this problem is this. We have to first of all understand this equation here. We know that delta P is equal to the final momentum minus the initial momentum. Now, if I transpose the initial momentum, I take it to the other side of the equation, I will have Pi plus delta P equals to Pf. This is how we approach the problem. Okay, so we first of all need to draw the vector for the Pi, then we go to the delta P, and then lastly we draw the vector for the final momentum, but starting at the tail of the Pi and ending at the head of the delta P. In this example here, we're given a ball which is having a mass of 300 grams, and it's striking a wall at a velocity of 15 meters per second, and it bounces off that wall at a velocity of 9 meters per second. So what we want to do here, we want to calculate the initial momentum, and then we want to calculate the final momentum, which is our Pf, and then we'll then determine the delta P, change in momentum, and then lastly we'll draw a vector diagram to illustrate the relationship between these three. So let's start. Now, we need to take one direction as positive here. So let's say taking right as positive. Alright. Now, it means that this velocity here is going to be positive. This one is going to be negative. Right. Now, let's calculate the initial momentum. Let me start from this side. My Pi is going to be equal to mvi, right? Mass times velocity. So the mass is 0.3 divided by 1000 multiplied by 15. So 0.3 times 15 that gives me 4.5. So I have 4.5 kgs meters per second, and this is to the right because I've chosen right as positive, and my answer is also positive. Next, I'm going to calculate my final momentum. So I'll say Pf is equal to m times the final velocity. The mass is 0.3. The velocity is going to be -9. And then that should give me 2.7, definitely, by -9. So I get -2.7 kgs meters per second, which is equal to 2.7 kgs meters per second to the left. Alright, now next up I need to calculate my change in momentum. So this one's going to be very easy because I already have my initial and final. So I'll simply say my change in momentum is equal to the final momentum minus the initial momentum, which is equal to -2.7. So I take this one with the negative sign, minus the initial momentum is 4.5. So if you subtract this 2, alright, -2.7 minus 4.5, that gives us -7.2 kgs meters per second, which is equal to 7.2 kgs meters per second to the left. Right, nice. Okay, now I have all my three vectors. I now need to draw a vector diagram to show the relationship between all these vectors. Okay, now we said you need to first of all draw the vector for the initial momentum. So the vector for the initial momentum is pointing to the right. Okay, so I'll draw a vector, an arrow which is pointing to the right. So that's my initial momentum. Okay, so it's not drawn to scale, it's just a sketch. Then I now need to draw the vector for the change in momentum. Alright, my change in momentum here is 7.2 kgs meters per second to the left. So I must start from this particular point here, and then I draw a vector to the left. So I'm going to draw an arrow pointing to the left, and it's much bigger than the first vector there. Yeah. So this one represents the change in momentum, delta P. Okay. Now, next up, I need to draw the vector now for the change, for the final momentum, race for the final momentum. But for me to draw this, I need to start at the tail. So I must start at the tail of the first vector to the head of the last vector. So you can see that your change momentum here is to the left. So you're just going to draw an arrow which is pointing to the left, but starting at the tail of the first to the head of the last. So I'm going to start at this particular point here and draw an arrow pointing to the left, but it's ending here, right here at the head of the change of momentum. Right, so here is my vector diagram here. So this is our P final. So that's how we draw a vector diagram in momentum. So just a quick roundup. For you to draw a vector diagram, you need first of all the initial momentum, you need the final momentum, and you need the change in momentum. So when you're drawing now a vector diagram, first of all, start with the vector for the initial momentum, then go to the vector for the change in momentum, and then lastly draw the vector for the final momentum from the tail of the first vector to the head of the last vector.